recording. Okay. Yeah, we can start.
Okay. Hello everyone. Hello to everyone who's watching this after the fact. This is workshop 2, I'm pretty sure. Yeah, technically workshop 2, week 3. We're going to be covering a decent amount of stuff. We're going to be covering prefabs. We're going to be covering nav meshes, making making the enemies move, and we're also going to be covering creating a spawner to just spawn any kind of game objects you want. Fingers crossed if we get to that, that would be nice. So starting off with prefabs, if we open up, for example, if we open up sample scene, we'll see that we have this cube, we have this main camera, we have a directional light, we have a platform, right? These are single instances of game objects. These are unique to a scene. We don't need to have multiple copies. But what if, for example, we wanted to create a new 3D object, a new cube. Let's call this item. Oh, I've got caps lock on. That's not ideal. And let's reset its position because I quite like everything to be 0, 0, 0. And you know what? Let's yeah, okay. Say we have item, and we want to have multiple instances, right? Because we want to have multiple things that we can pick up. What we could do is simply Control C and Control V, paste it a bunch of times, and then we can like manually place these. We can put these wherever we want in the scene, but that would mean copy pasting, and copy pasting is bad because if we have a change in item 0, as it were, like say we wanted to make it a trigger collider, we now have to go through every single item and manually change it to a trigger. Obviously, we're lazy. We don't want to do that. So there's got to be a better way, right? And luckily, you know what? Let's delete that as well. Luckily for us, there is. And that's what Unity calls prefabs. So create 3D object cube. Probably shouldn't have deleted it, but we're going to call it item again. We're going to 0 its position. And what we're going to do now is we're going to drag it. We're going to go into assets, and we're going to create a new folder called prefabs. Oh, yeah, get rid of that. Oh my goodness, I've messed up. This is a bit impromptu, but you know what? It's fine. It's absolutely fine. Okay. There must have been materials there. Not to worry, we'll fix this in a second. Oops. 3D object, where is it? Plane. We're going to make this 10 by 10. That's good enough for now. You know what? -1 as well, just for good measure. Cool. So we've gone to assets. We've created the prefabs folder, and in here we're going to drag it from. We're going to drag the item from the hierarchy to the prefabs, and it'll create our little item prefab. If we double click, we'll be taken to an editor specifically for prefabs. And here we can edit the properties the same way that we could when we were in the hierarchy. However, now if we go back, we'll notice the item is blue. This means it is an instance of a prefab, and instances of prefabs are exactly the same as classes and instances of classes, right? The class is the template, and the instance is a concrete, like it's an instance. I don't know how else to explain that. It's like it's got actual values instead of just being like a blueprint. Instead of being a blueprint, it's real, it's defined, and it's got real values. The same thing with the item. If we now drag this item prefab into the scene, you'll see that another item is created, but it's also blue. And we can reposition this exactly the same as if it was another game object, except that now if we edit the prefab, so we set it to be a trigger and we save, item 1 has automatically had its collider be a trigger, instead of us having to go and manually and do it. That's what's really cool about prefabs. Now, to distinguish this item from our player, which is currently pink, we're going to go into assets. We're going to create new folder, and I'm going to call this materials. we're going to create a new material, and you know what? We'll call this default material because yeah, I may or may not have forgotten to do that. I may have destroyed it accidentally. It's fine. We've now got default material, but we want to have the item look different, right? So let's create a new material. We're going to call this item material. We're going to go over to the inspect. So we select the new item material in the project pane. We go to the inspector, we go to albedo, and you know what? We're going to make it nice and yellow because who doesn't love a nice yellow color? Bees and whatnot. Now we go to where is it? Yeah, so prefabs. We open up the item. Then we can go back to materials and we can assign it by just dragging. And now we've got a nice yellow cube. And you know, this is quite big. If we go back into the sample scene, yeah, you see that both of the prefab instances have changed. We see that this item is, you know, it's quite big. It's the same size as a player. Might be mistaken. I'm not sure. It's different color, but maybe, right, at a glance. So we want to go into prefabs again. We want to open the item prefab and let's scale it down to 0.5 in all dimensions. If we now go back, we should see it's much smaller. Okay. And you know, this at this point, it doesn't have anything. It has a transform. It has, let's actually double check. It has a transform, it has a collider, which is a trigger, and it has a mesh render and a cube field. That's all fine. Doesn't do much. If we go into the scene, you see it doesn't do anything. It doesn't interact with the player at all. Okay, let's make the items do something, right? When you think of an item, you don't generally think of it just a static thing. Maybe it's a bit shiny, maybe it's got a few particles. In our case, it's going to rotate. So we go to assets, we go to scripts, we right click, create C# script, and let's call this rotator. And in my case, it's opened it in it's opened up Unity. But let's pretend that didn't happen. So then double click and open it in your editor. And let's scrap all of this default nonsense because it's not necessary. What do we want to do? Well, we want to have a serialized private variable so we have something to tweak. In our case, it's going to be rotation. We're going to want this this item to rotate around its own axis. So we're going to have that as a parameter to the script, effectively. Because we're doing some rotation and this doesn't have to happen every frame, what we can do is just put it every physics frame. So we'll do a private void fixed update. And here we're just going to go transform.rotate. And it'll be what? Rotation times time dot fixed delta time. So that it'll interpolate based on how long the previous frame has taken. This ensures that it's nice and smooth rotation instead of, you know, either going too fast or too slow. Depending on the set, this is the more generic version. It's generally what you want to use. So save the script, return to the Unity editor. Wait a little bit for it to you know, actually notice that the script's changed. Go to assets, prefabs, double click on item, add a component, and we're going to do rotator. What's a nice rotation? Actually, any ideas from the chat, maybe? Any rotation you guys would like to do? Make it spin really fast. In what axis? X, Y, Z? Give me some values. So how fast should it rotate on the X? You know what? You just said go, make it spin really fast. Very fast. You know what? We'll go with 90 for now. This is actually going to be the rotation in degrees around the x-axis. So if you go to the transform and you see this rotation, you see how it changes. This is basically how much that's going to be changing. Okay, let's make it spin really fast. 45 and 30. Okay. So now our item, you know what, we're going to move this slightly. What's this at? This is 0, 0, 0. This will be at 0, 2. No, maybe not 2, maybe 5. Or minus 5. Okay. So now we've got a few items. Let's see how they spin. Oh, it doesn't actually spin too fast. Yeah, maybe that's a bit of a shame. Do you want to increase the speed? Disappointing. Yes, speed, cool. One thing to know about prefabs, when you edit the prefab directly, these are default values. So you'll see if I add another prefab into the scene, it's got the same default values. However, that doesn't mean that you can't change these individually. For example, you can change the rotation from 90 to 180, and it'll only affect this prefab. You'll see edited changed fields in the little blue marker. Fingers crossed. Let's put this somewhere else. -5, sure. That'll work, just so it's separate from the rest. Okay, it's going slightly faster. Okay, one more buff-in speed. It completes a full rotation every second. Okay, that's a bit weak. I can't lie. 10 rotations per second. This will be the last of my messing around with this, I promise. Aesthetics. We love it. Is that fast enough for you? So you can create instances of prefabs, you can edit their values. Okay, that's that. I mean, but you saw that I was going through another, like I was going through an item, nothing was happening. That's a bit boring, right? We want something to actually happen when we go over an item. And that's what we're going to be doing now. What I actually might do is edit the target position offset and rotation. You know what? For now, I think I'll leave it for now. We'll go back to that later. We'll just give collisions to these items. So, let's see. What we first have to do is we've got the box collider. Cool. Oh, let me just think. Okay, first we're going to actually create the script that collects these game objects on the player. So go to assets, scripts, and create a new C# script. Call this collector. Sure, that's a nice generic name. Maybe a little bit more generic than we would like, but whatever. Open up in your text editor, and as usual, just strip out the contents. It's not necessary right now. What we're going to have instead is we're going to have another require component. So this will mean that when we add this script to an object, if it doesn't have the component that we require, it'll be added automatically. And we want a collider because we want to register collisions between the game object and items. We're then going to add a private variable, private game object, stateful. Okay, I'm going to explain this in a sec. We're going to add a property score, and then we're going to have to add the start method. Pardon me. We're going to add the start method, so stateful item equals object. I'll go through this in a sec. Stateful item root dot name. And I'll explain it all in 1 second. Let me just add the final. We need an on trigger because since we want to collide with game objects, because we're going to use a trigger collider because we don't actually want the player to bump into these items, we want them to just pick them up as they go over them. We're going to have a trigger. So on trigger enter, collide other, cool, and we want we want to set reparent the transform equals stateful item dot transform. And what else do we want? We want to, do we want to, okay, we need to disable it as well. Other dot, oh, I might be messing up. Transform, okay, yeah, we can't set it. We have to set the parent transform. My bad, that's what I was complaining about. And what do we want to do? Okay, we want to set the dot active. No, game. I may or may not be a little bit tired. So sorry about this. It's getting a bit tedious. And then finally, we're just going to increment the score, and we're going to log it to the console. Log, and we're going to use the fancy interpolated string. This is to minimize heap allocations. You can think of it as free performance. It doesn't matter now, but one, it's a nice way of printing strings, and two, if you've got thousands upon thousands of string allocations, it'll have an effect. And using interpolated strings helps to lessen that just slightly. So we might as well use it. Plus, I think you'll see for yourself that the format for including variables, given the lack of concatenation, for example, we couldn't have done score, right? That doesn't work because score and string are different types. Unless I'm lying. Please don't tell me I'm lying. Okay, so string has an overloaded operator to actually accept anything. Well, my bad. My bad, but this is quite nice, right? The alternative would have been to do debug.log current score and then plus score. And especially if we wanted to have something afterwards, we would have to then do and personally I find this form much more readable. So this is the form that we're going with. Plus it teaches you about interpolated strings. This is apparently also available. We're going to ignore that. We're going to ignore that for now. So what have we actually done here? We've created a collector script. It requires that the game object it's attached to already has a collider component. This basically is a reference to a game object in the scene. And this is just a property that will allow other scripts to get the player score. Here, what I've forgotten to do is make it private set. Because otherwise, if it's public set, any script can edit it. We don't want that. We want private set, which is, so we've got a public property with a public getter and a private setter. Then in start, we have to create this stateful item route. I'll show you a little bit more of what I mean when I get back to the editor. But this will basically be where all of our items are collected. And then we also give it a nice name so we know what it is instead of having some game object one or game object clone or something, some meaningless name. We give it a meaningful name. In onTriggerEnter, so whenever we hit an item, we need to first change its parent transform to our collector, if you will. And then we need to make it not active in the scene so that it disappears. The player knows that they've picked it up. And just for fun, we also increment the score and we display it in the console. This is a bit more, this is a bit of overkill for what we need right now, just a simple picking up, but it'll come in useful later. Okay, I need to speed up because I've almost gone halfway and I've only got an hour left. That's our script. Save it, return to the editor. Okay, wait for it to go back. Okay, cool. And then we need to basically attach it to the parent. So going to parent, going to cube, which is our player, add component and collector. Awesome. So now, okay, it's opened. Awesome. What has it done? Has this script, it's overridden it, hasn't it? It's overridden it. You may be right, because right now I think we're on the default layer. We're on player. Okay, what we're gonna do is we're gonna create an empty game object. Call this collector as well. And we're actually just going to remove this. Yeah, so you might be right. It might have just collected the platform. um, oh, okay, that's cool. So if we add it from here, will it? Oh, okay. So it'll actually tell us that we need a collider. Box collider. It'll be a trigger collider. Then we add the collector's foot. So what you just saw there was a result of the require component. It popped up an error message saying that we didn't have the correct component already on the game object, on the collector game object. We were missing the box collider. So, it warned us and it told us to add them first. This collector is on the layer player. Okay, what we're going to do is we're going to add a new layer, user layer 10 in our instance, and just get the first free one, and we're going to call this collectibles. And then we go back to the collector. We put this on the collectibles layer. It will save the scene. And you know what? Just for good measure, go to item. So assets prefabs item. Open it up and put it on the collectibles layer as well. Then go to edit, project settings, and what are we going to do? So you see, this is our collision matrix. This basically defines which layer collides with which other layer. We only want the collectibles to collide with other collectibles. So what we're going to do is disable collisions between default collectibles, between this and this and this. All of these and collectibles, we're only going to leave it with itself, right? So if you hover over these little spots, it tells you what it collides with. So in our case, only collectibles collide with collectibles. Okay, awesome. If we do this now, it shouldn't, okay. You see, our current score was displayed in the console. This is great. I love this. Stuff works. So let's actually move this little item underneath, away from us. So 5, cool. Okay, so you see that our console's clear. When we collide with something, it disappears. Under collector, stateful item root, we see that it's now appeared there. And our score has been logged to the console. So if we collect this one, it's now 2. And if we go forwards and we collect this one, it's now 3. It's quite nice. It works. With only a few major, okay, stateful. This is a topic for a different workshop where we go over inventories. For now, you can just treat it as meaning anything. You don't need to really care what it means. What it means is that the item can't be recreated from a template. It has to store the specific values it has, right? For example, say you had 3 different, say you had a favorite toy of yours, and compare that. Okay, so you have a favorite toy. It's been yours for a long time. You love it for whatever reason. Maybe it's a teddy bear. So I have a teddy bear that I love, and I want to put it somewhere. If I'm very forgetful, and say my mother puts my teddy bear away for me, what she could do is either throw it away and buy me a new one from the store, which you could do. It's not very nice, but my mother could do that. Or my mother could put away the specific teddy bear that I had and then give that one back to me when I want it again, right? So that's kind of the difference. The store ones are the default ones, the ones that you've just created on the fly, where they didn't have to remember anything they were previously. Stateful, so that's stateless. Stateless don't care about their previous state. Stateful means that you need to care about previous state. In this case, say each item had like a unique value that we wanted to keep track of, like say an ID. We couldn't then just start recreating items because we'd lose the ID. Even like say it was durability. You drop your sword, it's got like 3 uses left. You pick it back up, you want it to have 3 uses left when you pick it up. I mean, you might want it to have 10 uses. Stateless is default. It depends how you do it. It's a topic for another workshop. I can't get sidetracked, sorry. We'll explain it when we actually need to cover inventories more. So I'm sorry for just leaving it for now. Just treat this as a fancy game object. Anyway, stop the scene. we've created our game objects, and they, our items. We interact with them. It's great. We've done the layers. Moving on, we're going to create an enemy prefab real quick. So we've got our items. Let's create a 3D object. Let's create a cube, and we're going to call this enemy. We're going to 0 its position, and we're going to go into project, assets, materials, right click, create, and let's create a material, enemy material. Enemies are, they're evil, they like to hurt us, so we're going to pick a nice red color. Red's scary. Red shows enemies. You think of red, you think of bad person, blood, I don't know, whatever you think of, as long as it's bad. We're going to move them slightly away from us. Let's do X, so -4. Oh no, let's go 5 and X. Okay, so we've got our enemy. You know what, let's just slightly zoom out. Okay, cool. So we've got our enemy. We want to make this a prefab because you're usually going to want to have multiple enemies that chase you and attack you. Maybe you even want groups of enemies to spawn when the player comes in range. Say you're making an open world game. You want enemies to spawn only when a player gets in range of their spawn point. You don't want to have them in the world to begin with, because then you're dealing with unnecessary entities. So we just drag it into the prefabs and create an enemy prefab. We see that it's blue. It's now a prefab, right? We need to then open it up to start editing it. Okay, we've got an enemy, but we might want to have it move, right? Right now, as it stands, we've just got it and it's empty, it's static in the scene. It doesn't do anything, it just floats there. No, it's kind of boring. We can't really interact with it. Perhaps we want it to follow us. Actually, first off, we're going to actually give it a rigid body so that it's affected by gravity. Okay, how are we going to get this enemy to move? We're actually going to be using the nav mesh component. So nav mesh agent, this is effectively an entity that moves on a nav mesh. Think of the nav mesh as just the terrain of the scene. In our case, it'll be the plane, but you could also have rocks and paths that your enemies or your NPCs could walk on. That's kind of the nav mesh. So, oops, I must have closed it. So we've got the nav mesh agent. When you're using a nav mesh agent, you're going to need to set any kind of rigid bodies to kinematic. In this case, kinematic means not controlled by the physics system, because the position of this game object will be controlled by the nav mesh agent and not by the physics system. It doesn't move by itself, it gets moved by the agent. We have to set it to kinematic so that it still tracks collisions correctly. So we've created the nav mesh agent. Okay. We go back to the scene, save it for good measure. Navigation. You see this little navigation tab that is here. It might have opened. I wasn't really paying attention. Sorry about that. But we've got navigation. We can go into bake. Okay, so I guess scene filter. This lets you basically select which things in your scene should be included in the nav mesh. For us, it doesn't really matter. So we're just going to go to bake. And here you can set up the radius of your agents. In our case, it's a cube, it's 1 by 1, so 0.5 is fine. Its height, yeah, it can be 2. Doesn't have to be, but it could be. The max slope they can climb up. So if you've got, for example, a 50-degree slope, the nav mesh agent won't be able to climb that. And there's also a step height, which is used for smooth walking up steps. And say the step height is too high, say it was 0.5, the agent wouldn't be able to climb over that. I don't think. I'm not sure. Don't quote me on that. We're going to click bake. Oh, come on. Does it not work? Oh, well, something's happened. What's happened? Oh, it's not work. Show nav mesh. Oh, I'm not sure what's happened. Oh, this is not fun. You know what? We're going to assume that it works. Oh, we'll see in a second. Anyway, we're going to assume that, fingers crossed, that it worked. Go to assets, scripts, right click, create, and here we're just going to call this enemy movement. We've got player movement, so now we're creating enemy movement. And open it up in your favorite text editor. Get rid of this not useful stuff. Yeah, let's get rid of start and update as well. What we're going to need is system. You'll see why this is needed in a second. And we're also going to do Unity engine.ai. This is where our nav mesh component lives. We're going to require a component type of nav mesh agent. Okay. And now what we need to have is a few private variables, just to hold some references in that. So nav mesh agent, enemy nav mesh agent, kind of verbose names. Private bool is paused equals false. So this will store whether our enemy movement script is currently paused, if it's following the player or if it's not, and private float stopping distance. This will be the distance from the player that the enemy can stop. So instead of going onto the player, specifically to the player's current position, so instead of trying to go into the player, it'll stop this distance away from the center of the player, right? Then we're going to create a new property. So public float stopping distance. You might wonder why we've got this, since we have a private version. And the reason is so that we want a private get return stopping distance, and we want a public set stopping distance equals value, and enemy nav mesh agent dot stopping distance equals value. Okay, one thing to note: where the hell does value thing come from, right? We didn't declare anything. When you're in a property and you're in the setter, if you think properties basically convert to the following methods: public void set stopping distance value. So in our case, it'll be float, and public float get stopping distance. Oh, actually, it's going to be private. So these are the two methods that are created by this, effectively. This is just syntactic sugar for the following. So in our case, value is this little parameter here. Cool, hopefully that makes sense. Okay, we can now set the stopping distance from other scripts, which we might want to do, and we'll see why we want to do that later. What do we have to do now? Well, the nav mesh agent basically goes to a specific position, but we haven't told it what position to go to yet. So we'll have another property, this time for a transform, and this will be the target private get, and you know what, we're going to have to set as well. You might ask, why didn't you do it the same way as you did with the stopping distance? And the reason for that is transform, we don't have to do anything special. We just need to basically we just need to set a variable. We need to get a variable. With stopping distance, we had to both set this little variable here for y, we'll see later. It's to do with the calculating the distance between the player and the target, and knowing when to stop the script, when to pause the script. We also have to set the enemy nav mesh agent the stopping distance. Otherwise, the agent wouldn't respect our stopping distance. It would still try to go to the exact position instead of going to the position plus or minus our stopping distance. So because we had to do two things whenever we set the stopping distance, we had to essentially do a custom setter. And that's also why we have this backing field. That's a technical term for it. We have to store the actual value somewhere. So we've got a separate variable and a separate property. Hopefully that makes sense. Anyway, we've got a target, we've got a stopping distance. Next, what we might want to do is a start or an awake. No, it's awake because we're doing something on our game object. Awake And here we need to do enemy nav mesh agent equals get components nav mesh agent. Right, there we go. So this will fetch the reference to our nav mesh agent when the script starts. We also need a fixed update because we're dealing with the rigid body. Essentially, we're dealing with the navigation, like the nav mesh agent, but that doesn't have to happen every frame. It would be wasteful to do it every frame because it at the end of the day it affects the rigid body, and that should be updated on fixed update. So that's why we're going to do it here. If we're paused, we clearly don't have to do anything. Also, what happens if a target hasn't been set? What happens if target is null? Well, we don't want to they later use target like transform or target dot position. We want to just skip the current update. So we'll just do a quick return. Otherwise, if we're not paused and the target has been set, if the distance between the target and the current like transform position, so transform dot position and target dot position, if the distance is less than the stopping distance, if there's less than the stopping distance, yeah, we'll do that. Oh, you know what? I've forgotten something. So okay, we should have done the event first and transform dot position. Ignore that for now. Is pause. We want to pause the script. So if we're within our stopping distance of the target, we need to pause. We've reached the target. We don't need to do anything else. Otherwise, if we're not within that stopping distance, enemy nav mesh agent dot target. Oh, what is it? What is it? What is it? Destination? I think. Yeah, it's destination. Equals target dot position. We need to update the target destination. So perhaps the player has moved from their last known position. So we just need to update the destination in the nav mesh agent. Okay. Now I had just written reached target. What is that? Well, that's going to be an event. So public event. This is where our earlier using system comes in, because actions defined in the system namespace. We want to have a vector3 for now, and we're also going to, what we're going to call this, reached target. Okay, and now we can, do that. So what does this line do? If the reached target is not null, and remember that events are only null if they haven't had any handlers assigned. So if there's never been a call to reach target plus equals plus, if something like this has never been called, this will be null, right? That's a lambda function. That's actually a bit too complex. You don't need to know about that. Hopefully it's not too confusing. Anyway, we pause. So if we have any like listeners to the reach target event, we'll invoke them. We'll notify them that we've reached the position. They can do any code they want to do now. And then we pause the script. We never unpause this script, which that might be a problem if our enemy goes to the player but then never actually starts following them again. So what we're going to have is actually another method, private void resume, and what we're going to do is just set is pause equals false. You may have noticed that I've made it private, and you might think, why is that? Don't we want to call it? Well, we do, but we don't necessarily want it to be called all the time. Why is that? Well, maybe we have an animation. So the enemy reaches the player, and then an animation places. The enemy attacks the player. We don't want the enemy to start following the player in the middle of their animation. We want to wait for the animation to finish, wait for any cooldowns to finish on the attack or whatever the enemy does when it reaches the player, and then we want to set it to resume. So we can't have other scripts call this method, but what can we do instead? How do we get other scripts to resume tracking? Well, notice that we have this reach target method, which other scripts will use. So why don't we just pass it in here? Resume is a method returning void, and it doesn't have any parameters. So we can use the system.action delegate, which is a method returning void with no parameters. Here we've got an action with 2 parameters. Here this is an action without any parameters. You'll notice that this little invoke thing has turned red because now we're no longer passing the correct parameters. So we just need to add our resume here. This might be a bit weird. You're passing a function. I'll explain more about that in a bit. However, we now have enemy movement, right? We save, we go back to the editor. Wait for it. Unfortunately, nothing happens because even if we go to prefabs enemy and we add the component, what should this be called? Movement, enemy movement. We add it and we go back to the scene. Nothing should have changed because we never actually set destination. Did I forget to set it? Okay, so no, we don't have a valid nav mesh. Why is that? I need to know. That's not good. Oh my goodness. You know what, we're going to call this static. Okay, is that all stopping baking? That would have been very annoying. Bake. Okay. So if you don't have your platform, or in my case plain, because I accidentally deleted the platform, if you don't have it as static, so inspect it and then tick this little check mark, do that, and then the nav mesh will bake. So you see how now it's nice blue. If we now play, there shouldn't be an error here. Okay, it's actually, you can see that it's hovering a little bit, but this is the nav mesh agent now controlling the enemy. The enemy still doesn't attack us, and this is an issue because we want the enemy to, we want the enemy to navigate to us. We want them to do something when they reach us. How do we do that? So go to assets, scripts, right click, create script, so create C# script, and we're going to call this enemy behavior base, and open it in your, oh no, wrong one, we want enemy behavior. Fingers crossed, Visual Studio doesn't die on me. That wouldn't be nice. Actually, any questions so far? Could you skip the return code for the getter and stopping distance? Let's see. So enemy movement. Where? Here. Not necessarily. So can we? You see how here we've assigned stopping distance? We've used a custom backing variable. C# doesn't know what to do with this, right? Because we've declared our own block, our own method body, it can't automatically generate one. So we have to actually declare what variable we're getting. So in this case, it's return stopping distance. Oh, whoops. In this case, it's stopping distance. When you declare, like in here, what C# actually does is declare a private transform target. Right? It declares its own variable that's completely hidden from you, and it uses that in the getter set. It does default implementations, and the default implementations are something like, oh my goodness, I'll quickly implement it here, just for sake of argument. Private get return target set target equals value. This is what a property effectively does when you don't declare the custom setter or the custom getter. as soon as you declare a custom thing, you have to declare the other one as well, because C# doesn't actually know how to handle a get, how to handle a set once you've given up control. Hopefully that's answered your question. What do I have? Private get and set. We can get rid of this. Awesome. What were we doing? We were assets, scripts, we had enemy behavior base. Okay. We need to speed up slightly. So you're here using system, because we're going to be using events later. We want to require a component. So require component type of, it'll be a sphere collider? Yeah. Sphere collider, I can spell, that's nice. And we're going to have a private sphere collider, enemy tracking range collider. This is going to be useful so we know when the enemy should start tracking the player and when the enemy should stop tracking the player. Okay. Next, we need to basically have some parameters to the script. We need to have some serialized fields. Serialized field, private float base tracking range, serialized field, private float active tracking range, and also serialized field, private float attack range, and serialized field. I think it'll be a private float cooldown. Private float, yeah, attack cooldown, because we've got range as well. These will be useful when we like this define the behavior of an enemy in just a second. So then we need to do some other stuff. So yeah. So if you remember back to like I think it was workshop 1 actually. So last week's workshop. Oh my goodness. I'm typing and trying to talk and it's just not working. You'll remember that we cautioned against having inheritance. Inheritance in the thing. I can't speak and do stuff at the same time. I'll just type this out and then I'll explain. Public float attack range. Attack range. Get return attack cooldown. Okay, so in workshop 1 we cautioned against having protected fields and virtual fields. Okay, no, we didn't caution against protected, we cautioned against virtual. You'll see why this is important in a second, because okay, next what we're going to do is we're going to actually do the thing I just warned against, virtual void awake, to fetch references to our fields, right? So because we need to initialize the enemy tracking collider. Oh, I'm gonna have some explaining to do. It's gonna be great fun. And you know what? We'll also do the movement controller. Get component in parent, and this will be enemy movement. We'll have a start as well, so protected virtual void start, because we need to initialize movement controller. So if you remember, we had in movement controller we had the stopping distance. So we're going to need to set that now. So movement controller dot stopping distance equals what was it? Attack range, I think we called it. Yeah, we called it attack range. Oh my goodness. And do we need to do this? Yeah, we might need to. So enemy dot stopping distance. Did I not have it? Oh, I'm not sure. So sphere collider dot what is it, radius? Yes. So base tracking range. So this collider will function as our range detection. So when the player goes is hit by this collider, it'll be a trigger. So when the player enters the trigger collider, we'll start tracking them. And so the enemy will start following them. When the player leaves, it'll stop tracking. That's why we need to set the base tracking range so that, we have a reasonable default so that we can change exactly how far away the enemy sees the player. Oh yeah, because now, okay, so just bear with me, please. Avoid on enable. Make this virtual as well. It's not fun times protected virtual void on disable and protected. Okay, this is gonna have to happen at some point. Abstract void on reached target, and this will be a vector 3 position and action. This is why we had to have the this using system the namespace. You notice it's red and it's an abstract method. We're going to want each custom behavior to implement their own version, because there's no generic versions generally applicable to all of the different methods, right? Each one might want to do its own thing. Pardon me. So what we're going to have to do, because you can't have an abstract method outside of an abstract class, because then it's not guaranteed to be implemented, we need to mark the entire class abstract. This now means that we can't, because it's abstract, we can no longer do this. We can no longer have enemy behavior base equals new enemy behavior base. We can't do that because it's specifically because it's abstract. Instead, we can only assign new child enemy behavior. If child and enemy behavior inherited from enemy behavior base, we can do this. We can't assign a regular instance. Okay, we'll fill that in a sec. Actually, no, we can fill the views now. So you remember in the movement control we had a dot on reached target, right? So reached target, yeah. Well, now we can assign the callback on reached target, and on disable movement controller dot reached target minus equal on reached target. So we no longer have memory leak. It's all good. Most of our skeleton code is now done. Most is done. We just need to now do a few final methods. So a protected virtual void on trigger enter. Oh, come on. Collider and other. And a protected virtual void on trigger exit. Collider other. Fingers crossed my voice doesn't fail me. That would not be nice. So what happens when another game object enters our range? Well, first we want to make sure that it's the player. And one way we can do that is by checking the tag. We haven't done this previously. We've used layers to organize the collisions. For now, we're going to do it tag-based, just to show you how that's done. So if the other tag equals player, and if we're not currently tracking a player, this is important because if we've accidentally tagged two different game objects as player, but we're already tracking a player, we don't want to suddenly switch, right? This is more of an insurance. Plus, it just doesn't make sense to, whilst you're tracking a player and they're not dead, suddenly switch. I mean, it might make sense, but we don't want that necessarily. So for now, we're going to ensure that it doesn't happen. And tracked game object equals null. So if it hasn't been set yet, well, we need to do enemy tracking range collider dot radius. We need to set it to active. Well, we don't have to. This is what we're going to do in our game. So these are going to be separate, so you can assign them separately, because you might want it to be the case that when the player alerts an enemy, the enemy can track them for much longer than it usually could. And that's what this allows us to do effectively. And the alternative, sorry, pardon me, I'm yawning a bit. I don't know if it's audible on mic. It's a bit late. So if other dot, actually other dot game object equals track, yeah. So when a game object exits the range collider, we need to compare it to the currently tracked object. If the currently tracked object has left, well then we can just set the enemy tracking to base radius, base radius equals base tracking range, and we can leave other stuff up to more specialized scripts. You'll see what I mean later. Is anything really unclear at this moment in time? Hopefully not. Okay. The difference between virtual and abstract is that abstract cannot have a body, as you noticed. It has to be implemented in the child class. Virtual doesn't have to be implemented. If here's what I mean. Protected virtual void through and protected abstract void var. So this is obviously virtual. What we can't do, I don't think, we can't not give it a body. It has to have a body, a default implementation. And it can be overridden in child classes. It doesn't have to be. You can completely ignore this method and it'll still work. It'll just call the base implementation. Abstract is the opposite. It can't have a body. If you try to declare a body, it should throw an error. Yeah, it cannot declare a body because it's been marked abstract. This must be implemented in the child class. You can't just leave it to another. You can't call the base implementation because there isn't one. It's slightly stronger than virtual, in my opinion. Okay, we've done this. We now need to. So we've got our like behavior. We're just gonna create a new thing because why not? Behavior. It'll help us. Come on. You see. We can't do it in behavior because it's abstract. We have to actually implement some behavior. You see, this is something I've forgotten. Okay, I have to speed up. Oh no, there's not enough time. There's just not enough time. Scripts, and we're going to create 2 new C# scripts. Enemy behavior melee, and we're going to. Oh no, it's opened it. Create C# scripts, enemy behavior ranged. So we're going to just create 2 enemy types, ranged and melee for now. We might extend that later in the tutorials, in the workshops. We might not. But for now, I think that 2 is enough. So where are they now? We don't have to find them because we can just go in here and find them. So let's implement our melee first. So we scrap all of these. Don't need this. And instead of inheriting from mono behavior, we'll inherit from enemy behavior base. You'll see this now comes up right. This is because we haven't implemented the abstract member. So what we have to do is we have to, oh, come on. We have to, we have to implement this method. The simplest method for now, I think, is just to do resume. We can invoke the callback. This will just start tracking again. So as soon as it reaches the required position, the enemy will start tracking it. This effectively removes the differentiation. They'll just continually track the player at this rate. We'll change. Oh, that's very ugly formatting, but we'll change that in a sec. But before we do, I'm going to have to explain coroutines. Using system. Okay, and here we also have to do enemy behavior base. We'll implement the abstract class. We'll just, we'll resume the tracking callback. Okay. This one has been a bit scuffed, I can't lie. Okay, so head to assets, head to prefabs, and go back to your sample scene. So right now we've got one enemy type, right? We've got this red enemy, but we've just created 2 scripts. We've created a melee and a ranged like behavior. we need two different enemies. We could create a completely new enemy from scratch, but a nicer way of doing this would be to simply we drag the enemy in, and then we can drag it back. Right, so we're currently, this is a prefab instance, but we're dragging it back into the to create another prefab. We could create an original one, or we can do a variant. For now, we're going to do a variant. Okay, you know what? This is not very well named. Yeah, let's get rid of that. Let's call this enemy. Let's call it enemy ranged. That sounds good. Oh, that's not a D. That's not something that happened. Enemy ranged. Okay, and we're going to drag that back in and create a prefab variant. So now we can edit this prefab. I'll go on, open it. Where you see in the behavior, did I not add it? Okay. So go open up your original enemy prefab. So assets, prefabs, and enemy. Go into the behavior, add component, and now we can do melee. Oh, it's added the collider in here. That's nice. I'll set the collider to a trigger collider, and then set this range. So for example, 5, this will be 10. Our attack range will be 1 unit, and our cooldown will be 1 second. Let's call it a second. We've now configured our default melee enemy. If we open up the ranged enemy variant, we'll see that it's already been populated. So this is a prefab. It's inheriting the previous settings. However, because it's a variant, and what we can do is we can just straight up remove the component. It's fine. And then we want the ranged version. So here we're going to have 10, maybe 20. That's quite nice. Attack range will be 5, and our cooldown will be 2 seconds. Go to assets, materials, and we want it to be slightly different from the other enemy, so we're going to create a new material. So the enemy material 1. Well, you know what? Enemy ranged material. No, okay. Let's actually call it enemy 1, enemy material 1, enemy material 1, because it's not that special. Let's make it green. Everyone likes green. And then simply drag it onto this. So our variant is now green, so it's different. We might want to change this to 7, say, to actually move in different points. Cool. We've done that. Now we have, you know what? Yeah, okay, there's still something we have to do. So, okay, you've created the new variant, you've given it a nice little material. Okay, assets, scripts, and which one is the correct one? Okay, melee. Now to actually wire up the tracking. Protected. Oh, no. Protected. Override. And on trigger exit. Protected. Override. On trigger exit. On trigger enter, on trigger exit. Because we haven't actually set the movement control to track the game object that's collided. If you remember in the base, we just did the range. We did the range calculations. Okay. So above the base, if other.tag equals player, and then tracked game object equals null. So if we haven't set it and we've collided with the player, tracked game object equals other.game object, and movement controller.target equals other.transform. So we start tracking the player, and we basically start following their transform. Similarly, in onTrigger exit, we're going to have to do if tracked game object, or no, if just to be consistent, if other.game object equals tracked game object. Yep. Well, we have to then, stop tracking. So track game object equals null, and movement controller start target equals null. Generally don't use null, but it's fine to use it here because you can't track anything if you've lost the target, right? Here it makes sense, but don't use null sparingly, because otherwise you're going to run into a lot of null reference exceptions, which aren't that fun to deal with. Okay, so that's melee. Well, generally you shouldn't copy paste, but we're going to make an exception here because this code is pretty much identical. You could move this into yes, copy and pasting is the backbone of coding. At least when you're very tired, like what I am. You could move this into the enemy behavior base, and then you would only have to call based on trigger enter, or you could not even define these. But perhaps when you've got a ranged enemy, you want to show a mark on your player that you're being targeted. Pardon me. So you'd want to do that kind of stuff here. Start the animation here, which is why we don't in this case. You could abstract it out. You could move it into the base though. If we then save the script, go back here, it should, in theory, if I've done this right. Okay, it's not. It's not doing anything. Why is that? Okay. I'm not entirely sure what I've done. Oops. Is trigger default? Yeah. Oh, what could be the issue? What could be the issue? I'm not entirely sure. Let's change this to 5. Zajmie mi to trochę. Sorry about that. Okay. Oh, I'm not entirely sure what's going on. We'll come back to this. I can't really show. This is an issue. You know what, let's assume that it works for now. We'll move on to creating the spawner, and then we'll debug this if we have time afterwards. So yay, we finished the enemy and the enemy ranged. Go. Now we want to spawn stuff, right? We want to spawn perhaps the items. We want to have them be created all the time so that the player can collect them without being killed by the enemies. And we're also maybe going to want to have enemies spawned all the time, right? Because having 2 enemies that chase you might be a bit boring. Perhaps we want to have enemies continually group up, and maybe if you'd like, you could implement a lifetime system so that the enemy dies after a given lifetime, and then more respawn in, and that's one possibility. There's an infinite number of possibilities. We're just going to create a nice generic spawner that will allow us to create instances of any game object, any kind of prefab. So right click in your hierarchy, create empty. Nah, you know what? We're going to create a sphere because a sphere is cool. Name it spawner or similar. 0 its position because we like it when stuff is zeroed. And you know what? This can be can have it very far away from the player. Go to assets materials, and you know what? You can put whatever material you want on there. We're gonna create an item spawner for now, so we're gonna make it nice and yellow, so it's the same as item. Go to assets, scripts, right click, create C# script, and call it spawner. And you know, oh, please don't open. Okay, you can also just drag it onto the game object to add it as a component, and you'll see that it's now been added. Open it up in your favorite text editor. Get rid of the previous stuff, which we're gonna actually, now we get to leave these. They'll come in useful later. We're gonna have to give some parameters to the script, because we would like to decide what we spawn, how often we spawn it, in what kind of area do we spawn it, whether we spawn one instance and then stop, or whether we spawn multiple instances. So to that end, we'll have a few serialized fields. So private game objects. Yeah, we're gonna have multiple. Source prefabs. Serialized fields. Private float cooldown seconds. Serialized fields. This will be our maximum spawn radius. So we're planning on doing a ring. So you'll be spawning your objects in a ring around the spawner. That's why we have the radii. Serialized fields, private float, spawner height, and the final serialized field, private repeats. Repeat. Yeah, okay, repeat. Private void. Repeat. Yep. But I haven't actually spelled it right. Thank you for catching me out. Repeat. Repat? I don't even know what I put. I'm not sure I want to. We actually also need another variable. Well, yeah, we need it. And I'll explain a little bit more later. Okay, and now we can move on to private void start. We're just going to call this start spawner method, which for now you don't have to worry about. We'll implement it in a second. In fact, do we want to? Yeah, you know what? I'll implement it now. So private void start spawner is active. Oh no. So if not is active. Yeah, we have to if it's not active yet. I have to explain coroutines first. Okay, well, for now we're just gonna have a stump method. And we'll also have an associated. No, okay. Private enumerator spawner coroutine. So previously we've seen the update, fixed update, late update, all those methods. They execute every frame. What happens if you want to do an action over multiple frames? How would you do that? It gets really tricky if you've only got update and fixed update, because you have to keep track of what frame of the action you're on. If you've got a very long lasting action, that gets difficult. It clutters up your update methods. What you want is to have some code running in the background. You want to have some code running in the background that'll execute and continually call back to you, as it were. This is where coroutines happen. They happen at the same time as your other code. That's the coroutine. It's happening at the same time. Cooperative, I don't know, but that's why it's called the coroutine. I'm rambling a bit, sorry. It allows us to have code execute in the background. Is active. So when we start the coroutine, well, we want to set it to true. So the spawner is currently active. We need to keep track of which prefab we're spawning. Source prefab index. We'll just spawn the first one for now. And you know what? We could do either a while true or a do while, but let's give do while some love. And do while. You know what? You know what I'm thinking right now? True. Is while is active. What are we gonna have to do? Yield return new wait seconds. Cooldown seconds. We have to instantiate a new game object. So source prefabs. Okay, let's split this up a little bit. So game object source prefab equals source prefabs source prefab index. Oh no, this is okay. Never mind. So instantiate source prefab. Yeah, I think we can just instantiate it. Oh no, we need to give it a position. Random position in ring, and we're gonna spawn it with the same rotation as our current game object. Then we have to do source prefab index equals source prefab index plus 1 modulo the source prefabs dot length, right, dot count. Oh no, it is dot length. This wraps our source prefab index. So say we have 3 prefabs. When we reach the third one, we'll increment. So the third one is at index 2. When we increment to index 3, we want to wrap around back to 0. So that's what the modulo will do. After we're done, we have to set is active. Equals false. Why not? Why not? It's fine. Oh, actually, you know what we could do? Instead of this, let's assign this to repeat. Let's assign this to repeat. Because while we should repeat the spawner, we need to spawn more. Okay, so this is our coroutine method so far. You'll notice that random position in ring hasn't been implemented. Let's do that right now. Private, it should return a vector 3 because we want to have a position in the scene. And since we're having a 3D game, that'll be a 3D vector. Random position in ring. And here's where we're going to have to do a bit of trigonometry. Float theta. So first what we want to do is get a random angle in a circle. So a random ways around the circle. This will be our theta. So theta equals random dot range between 0 and math f dot pi. You know, 2, because in maths we have 2 pi. So, and what we also want is a distance from the center of the circle to the outside. So this will be our hypotenuse of our triangle. So this is why it's hypot random dot range, and this will be between min spawn radius and max spawn radius. So this will get us a spawn radius within the bounds we have set. Now comes the disgusting trigonometry part, where if you remember SOHCAHTOA, we just need to rearrange S over H. SOHCAHTOA. In our case, we're going to be using sine and cos. Sine equals opposite over hypotenuse, and cos equals adjacent over hypotenuse. So in our case, because we want to have the x and z, x will be our sine. I could draw this out. I had to draw this out, but I don't have pen and paper handy, and we're reaching the end of the session, so I'd just like to get through it. Sorry. You can ask questions later if you're not sure how to derive this. I'm sure you do though, because you're intelligent people. Theta and z equals hypot times math f dot cos theta. And finally, we have to return a new vector 3 containing our x, our spawn height, which is our y, and our z. Okay, we've now got a random position trig. Yeah, trig isn't my best friend, unfortunately. I have to get out pen and paper whenever I do it. This method now works. We still don't know what to do with our start spawner method though, right? What we might want to do is set repeat to true. Right, this will start the spawner spawning continuously. However, this will also have to start our coroutine, right? So we could do start coroutine. You know, you don't need a discard in here. Start coroutine. What is it? Spawner coroutine, right? You have to call your coroutine method, and then you just pass that to start coroutine, and it'll start executing in the background. What happens if we like start spawner twice. Because we touch state here, we should only ever have one instance of this coroutine running at once. Otherwise, we could spawn the game objects at different times and like, multiple times each second if you have a bad enough case. How do we stop that? We just wrap this in an if is active. If not is active, sorry, because if it's not active, we have to activate it. We have to start the coroutine. We've got a start spawner method now. What happens if we want to stop it? Private void stop spawner. It can't do anything except set repeat equals false, because repeat was the condition upon which we had our do while loop. So while we are meant to repeat, so repeatedly spawn stuff, that's why I have to set it to false here, and eventually we have to actually set these to public, because otherwise other things can't call them, and other scripts might want to start and stop the spawner. So that was a small omission on my part. Set them to public instead of private, and these will allow other scripts to control the spawner. One thing I haven't mentioned: why do we have a discard here? Well, instantiate actually returns the game object that was created. So whenever this returns, whenever this creates a enemy clone in the scene, it'll actually return it. So clone. Then we can start tracking this. We can change properties. So we could change the clone.name equals food bar if we really wanted to. We can modify it after the fact. We don't care about that right now. In your own spawners, you might. For example, you could keep a list of all currently spawned game objects, and this would be a way to keep track of those. So you could only spawn more when you have less than 10 game objects in the scene currently. You can assign them to a list. That would be one way to do it. And if if you find a space in the list, you can then spawn another one. Okay, yield return. This is how to explain this nicely. So yield return is something called, it's part of something called generators. Another name for them are reentrant functions. Basically, it allows you to call spawner coroutine multiple times. The main use case for this is in for each. Let me just quickly for each var in spawner coroutine. It doesn't, yeah. Not fun. Oh, do I have to do the next? So, sorry about this. I enumerator spawner next. Enumerator.next. Yeah. Generators get into the internals of C# a little bit. It allows you, it's what's used in the for each. So I enumerator float for each float f. Yeah, it's unassigned. I know. Basically allows you to use it in a for each loop. I don't know how to explain this very well. I'm so sorry. I should be able to explain this better. When this code hits this point, it'll pause, it'll return this value, and to continue execution, you have to then call the method again. So the first time spawner coroutine is called by Unity, this is specifically in Unity, it'll execute this line, it'll execute this line, it'll execute this line, it'll go to this line, it'll return this, and after it's returned, it'll stop executing. Unity will then wait for this many seconds, and then it'll call this method again. So the second time it's called by Unity, it'll continue from where it left off. So it'll spawn the actual game object, it'll do all this, it'll hit this, it'll go back to the top, and it'll wait for another cooldown seconds. Yield basically lets you go in and out of functions. It allows you to pause execution of a function until a later date when you call the function again. Hopefully that's clear. I'm sorry if it wasn't. I'll try to explain it a little bit better. Yeah, it's like a pause button. Yeah, exactly. Okay, we've got our spawner. It's got our script. Call that. Let's have a call that second of 110. Spawn height of 1. Repeat. Yeah, let's have it repeat. And okay, so source prefab. Click on in this point, click on the source prefabs. You need to set the size of the array first. Should min. Yes, they should. Good spot. Excellent spot. 10 and 1. So we'll set our size of the source. We'll set the size of the source prefabs to 2. Or go into prefab. Ooh. You know what? We don't have to because this is just an item spawner. So we'll set it to 1. We'll drag the item prefab into here, and it's now assigned. So if I haven't messed up, it should spawn. Okay. You see it spawning. It's spawning items. Okay, let's okay, where's the does the main camera have? Yeah, let's disable the camera tracker for now. Let's do 90 degrees and move this 10 up in the sky. No, 20 up in the sky. I'm gonna have 0. Just to show you more of what's going on. You'll now notice that these items are spawning within the predefined radius, right? If we change our spawner to say 2, fingers crossed it should. Does it not? That's a big shame. Do I have to I'll probably have to restart for changes to take effect. Okay, so this should in theory work there. We should spawn it really close. No, it's not spawning it really close. Why is that? Oh my goodness. That's what. Yep. Did you spot the bug? We've returned a random position in the ring, but that's around the origin. What we have to do is do transform.position plus random position in ring. Oh, the live debugging. We love that. Now it should be spawning. Yes, now it's spawning around the spawner. I promise you that it's not too biased. I don't know why it's spawning it so close together. I might have messed up the trig. Fingers crossed I shouldn't have. But yeah, it spawns, and if hopefully the cooldown seconds works. It seems to be spawning more often. I do wonder why it's like that. It seems. Well, we've created a spawner at any rate. Any burning question? Actually, we haven't finished the enemies. There's what we haven't done. Yeah, it's a little bit biased. And I don't really know what to do. Okay, we're going to go back to the enemy behavior melee. On recycle, we're gonna. Yeah, we have to do something else. Bear with me while I add these fields. Actually, no, we don't even have to do this because we've already created the attack cooldown. It's a property. Oh, okay. Okay, so in enemy behavior melee, create a private enumerator attack cooldown. I wanted to explain coroutines before I got to this. Yield return new, wait 4 seconds, and this will be attack cooldown. Did we not create the we might not have created the thing, enemy behavior base. Oh no, we have. No. Oh, here's something we didn't do. This shouldn't be called attack call. This should be attack coroutine because it's a coroutine. My bad. And we have to also add the using system.collections because IEnumerator lives in this namespace. So we've got the attack coroutine. Next we have to start coroutine. No, we don't want to stop. Sorry, my mind is failing me. What we need to do. Okay, here's how attack coroutine is going to work. Instead of calling resume track and call back, what we're going to do is we're going to do start coroutine, attack coroutine. But now, we can't ever resume because this returns immediately, and we want to start resume tracking when this is finished, so after hit. So we need to pass it in. Resume tracking callback action. What are we going to call it? Let's call it the same. Resume tracking callback. Oh, jeez. And then we just resume tracking callback. Cool. Now you can copy and paste this again. I just did it. Ignore the fact I copy and pasted. I swear it's for a good cause. So that should be good. Right, we're missing system.collections. Well. Yeah. Anyway, it doesn't do anything. I'm wondering why that is. And any questions that you have now that we've quote unquote fixed the enemies? Yeah, that's an excellent question, isn't it? It's meant to follow the player. It's meant to detect when the player has entered the range, and then it's meant to follow them. Let's, because we've split these apart now, right? We can have. Oh, I know what we haven't done. It's not even that, Diana. What have we? So we're checking the tag of the colliding game object. You know how I mentioned that we want to tag it so that we don't set the tracking to the wrong game object? Yeah, well, our player object isn't actually tagged. Oh, I'm so sorry, guys. Well, luckily, Unity has a built-in player tag. We'll set that, and this should work. Oh, look, they follow us. They follow us. It's great. So I've gone out of Red's range. I go back in. He starts following me. Oh no. You see how green's lurching? That's because they're attacking. They're in their cooldown. They've attacked. They're in their cooldown. When they stop cooldown, they start following me again. So red. You see how red stopped? They're in their cooldown. They're in their cooldown. They're out of their cooldown, etc. So our enemies now work. This is what the enemies were supposed to do all along. Our items are being spawned very rapidly by our friend the spawner. Let's see if we can, change that so that we have a max spawn radius of 10 again. Let's have a 5 cooldown. Spawn height of 0 because why not? And repeat. Cool. So in theory, this should now spawn them decently far away, or it might spawn them out of bounds of the camera. Okay, we collected it. So any other questions? No other questions? Are you sure? Because I guarantee you my explanations could have been a lot better at points. If there's anything you're unsure of, even if it was near the start. Okay. Thank you, Zoe. Yes, what's IEnumerator? Excellent question. It allows functions to be paused and then resumed at a later date. They'll resume execution at the moment they paused. It's used in generators, which are basically stateful functions. They'll remember their previous state, their previous variables and stack, and then they'll be able to resume when you next call them from that point. No. Don't let the name fool you. It's not an enumeration. Yeah, okay, we're going to leave it. It's not an enumeration. Internally, how they're implemented could be as an enumeration, but you don't need to know that. It's not an enum. Okay, an enum is its own thing. So if we go into here, and if we go into spawner, the public enum foo, this has nothing to do with enumerators at all. It's something completely different. Yeah, slightly misleading, but you get used to it. Because like you're enumerating the collection. That's its original purpose. It's a nice generic way of handling any collections. Like the for each uses them because then you can for each over loops, over no, not over loops. You can for each over lists, over arrays, over dictionaries, databases with some frameworks. It's quite nice in having a single for each thing hold true over a lot of different cases. No problem. Hopefully I've explained it somewhat well. Any other questions? No. Okay. Well, sorry for keeping you 11 minutes past when we were meant to end. Hopefully, you enjoyed the session. You learned a little bit. The recording will go up on the yeah, I'm very sorry. The recording will go up on the website at the end, so you'll be able to watch it there and watch me struggle with tags. Great fun. I guess next workshop's going to be on Wednesday, Diana?
We hope so. So if it's not on Wednesday, we'll let you know. But let's say for now, it's going to be on Wednesday.
Okay. Well, thank you very much for coming. do come on the Wednesday one.
Thank you, everyone. See you next week. And thank you, Mikolai, for presenting, and Andrei for being a TA as well.
Yeah, no problem.
Bye, everyone.